got a very important topic that's going to be running into your future for a long time, actually. You've probably all heard of a term by the name of CAN, Controller Area Network. And that's the way we data bus systems on these vehicles together. And you know, it's kind of interesting because robotics industry uses it, heavy truck manufacturing, and all sorts of computers are linked together with CAN technology. So it's a protocol that's really used out there, but we've got some huge changes in the automobiles, as you see. We've got brand new electric vehicles coming out, and those vehicles require all sorts of computing power. This is the backbone, as we call it. Remember, the grounds are important. Now, please keep in mind, if a data bus is down, you want to remember that we've got computers that are hooked up to that data bus. They need to be powered. So this computer needs a good 12-volt feed, and it needs a good ground. This BCM, same thing. Got to have a good 12-volt feed, got to have a good ground. TCM, same thing. Now, the requirement here is 12 volts pretty much. Remember, fully charged batteries, 12.6. These particular modules or computers will keep working until they reach a lower limit on their voltage, which could be somewhere around 6.8 volts, 10 volts, depending on the application. Let's go ahead and go a step further here. And we talked about the fact that you're going to diagnose pretty much through the diagnostic connector. Now, the diagnostic connector is going to give you the ability to hook a scope up, you can hook a meter up, you can do whatever you want. You can look for voltage. This particular picture shows the J1939-11 twisted shielded pair cable. A lot of the heavy trucks and such, they have actually a shield around the twisted wires. Let's talk about CAN communication real quickly because it's pretty important, and we're going to really get into CAN communication and CAN FD communication, but let's give you the basics tonight. The next session will be more complicated, okay? So here, if you notice in the PowerPoint, we have a typical CAN signal. And this is CAN high. Now, we said when the CAN signal is basically not functioning, it's basically sitting still, it's going to be at 2.5 volts. So right here at this point, you can see we're at 2.5 volts, so the CAN system's not doing anything. Which computer are we going to allow to talk? Because there's a pecking order here, right? Lowest numbered computer is going to go first, always. And then we have, in this particular case, the message identifier. It's an 11-bit identifier, and it's used for arbitration and priority. 7 bits are going to be used to go ahead and assign, very simply here, which computer goes first. So we're going to hook up our breakout box to it, so we can go ahead very simply there and make sure we get this handled. Do our diagnostics here. We're going to go ahead and do voltmeter diagnostics first, and then we're going to go ahead and do scope diagnostics on regular CAN systems, show you a bunch of problems and some issues that you could see with your scope.